Good morning to everyone. I am Nagendra from CSM department in Mlritm. Today, I would like to explain the subject machine learning. In this subject, I would like to explain the topic genetic algorithms. Here, I will cover what is the importance of genetic algorithms, what are the topics to be covered in the genetic algorithms. First of all, we need to understand what is meant by genetic algorithms. Name itself says genetic. Genetic algorithms are mostly used for evolve the solutions for the next generations. That's why the genetic algorithms are all called as evolutionary algorithms. Next, the genetic algorithms are more adaptive and heuristic search algorithms. Why we are call it as more adaptive? Because genetic algorithms can handle huge amount of data. It can accept any type of data. That's why genetic algorithms are called more adaptive. At the same time, genetic algorithms are also called as heuristic algorithms. Why we are call it as heuristic algorithms? Because for a problem, there are number of feasible solutions. Among them, we need to find out best and optimal solution. For that purpose, genetic algorithms are very useful. That's why genetic algorithms are called evolutionary and heuristic search algorithms. The basic operations of genetic algorithms are selection, crossover, and mutation. These are the three major basic operations of genetic algorithms which can be used to evolve the solutions for the next generations. Now, before entering into the genetic algorithms topic, first of all, we need to understand what are the basic terminology we are going to use in the genetic algorithms. Here, we observe term and meaning. Chromosome. Why we are taking as example or terminology in the genetic algorithms? Name itself says it is genetics. That's why we are considering this terminology. First one is chromosome. Chromosome is a candidate solution. This is the solution for the next generation. That's why chromosome. In the chromosomes, there are number of genes. A part of the chromosome is nothing but the genes. Population. Whenever we are considering number of chromosomes or number of candidate solutions which can be used to evolve the next generations, that is called as population. Here, next, fitness function. With the help of fitness function, we are going to be measure the fitness of the candidate solution. How much good enough this candidate solution for the next generation. For that purpose, we are using here fitness function. Next, generation. One cycle of evaluation or reproduction activity is known as generation. Next, after understanding the basic terminology of the genetic algorithms, now we will enter into the genetic algorithms. What are the basic steps involved in the genetic algorithms? Basically, genetic algorithms having totally 7 steps. We will discuss one by one. In the step 1, initialization. First of all, we need to gather the information or set of possible solutions for the next generations. With the help of this population or initialization, we are going to be implement the next generation. Here, generate an initial population of random candidate solutions. Here, population is nothing but the random candidate solutions. With the help of this population only, we are going to be evolve the next generations. So here, candidate solutions are nothing but chromosomes. Whenever we are observing here, this entire thing is known as the population. Here, I consider totally 4 candidate solutions: A1, A2, A3, A4. So A1 is one chromosome or one candidate solution, A2 is one candidate solution, A3 is one candidate solution, and A4 one candidate solution. All these 4 chromosomes are considered as the population. With the help of this population, we are going to be implement the next generations. When we observe here, A1 is represented as bits. Bits are known as here is genes. So one chromosome can have number of genes. So here we consider 4 chromosomes which can be used to evolve the next generations. Now, second step, fitness evaluation. After taking the chromosomes for generating the next solutions, we need to identify which chromosomes are good enough to generate the next generations. For that purpose, we need to calculate the measurements. how much good enough these chromosomes are for the next generations. For that purpose, we use calculate the fitness of each chromosome using fitness function. For suppose here we consider four chromosomes, right? For that, for each chromosome, we need to calculate the fitness value. A1, A2, A3, A4. For every chromosome, we need to find out the fitness value. After finding the fitness value for every chromosome, now we need to perform the selection operation. Selecting the best performing chromosomes. Based on the fitness value, we will identify which chromosome is good enough or which chromosome is more active to generate the next solutions. So, to do the selection process, we can use any one of the common methods: relative wheel selection, tournament selection, rank selection. With the help of any one of the selection, we will find out good chromosomes. After selecting the best chromosomes in the selection process, that chromosomes are considered as the parent chromosomes, which can be used to evolve the next generations. First, suppose here we observed A1 is a good chromosome and A2 is a good chromosome. These two chromosomes having the highest fitness value. That's why these two chromosomes can be taken as the input to generate the next generations. Here, so what is the step for here? Crossover, recombination. Combine two parent chromosomes to form the offspring. Whatever the chromosomes we selected in the selection process, with the help, we need to combine them to generate the new offspring. Here observe, A1 is one parent node, A2 is one parent node. How can we cross over here? Here I selected crossover point is 3. Crossover point is here is 3. We can take any value. We can take crossover point is 1, we can take crossover point is 2, like that. I am selected here is crossover point is 3. So I am exchanging the bits of A1 and A2. We are interchanging. A1 is interchanged with A2 bits, A2 is interchanged with A1 bits. Now we got two chromosomes, two new chromosomes. These two chromosomes are the child chromosomes of the A1 and A2. Name it as A5, A6. So these two new chromosomes can be added to the initial population. Now, this is the step 4, crossover. Next, fifth one is mutation. Mutation is nothing but the swapping. We can call it as swapping, or we can call it as exchange. After performing the crossover, whatever the result we got, we can exchange any one of the bit in that chromosome. Here, I am taking one small example. Before mutation, the chromosome is like this, 11011. After mutation, I am interchanging the value of one bit only. So, interchange or exchange or swap. That operation is known as the mutation. To get the variety of the inputs, we are doing this mutation. After performing the mutation, now we got one new, or we got two new offsprings here, A5, A6. Those two offsprings are added to the initial population. In the initial population, we have four chromosomes, right? After performing all these operations like selection, crossover and mutation, we got two more childs that are A5, A6. So these A5, A6 are replaced in the initial population, replaced with old chromosomes, or we can add directly. Then the initial population becomes 6 chromosomes. This process is continuous until we reach the solution or until specified criteria met. A new generation is evolved. Up to that, we need to do the same process. Step 2 to step 6. Next, what is the last step? Termination. Repeat steps 2 to 6 until stopping condition is met. What is the meaning of stopping condition? Whenever we found good solution, we found good generation. In that case, we need to stop. So, maximum number of generations are generated and desired fitness level is achieved. No improvement over several generations. In these three conditions, we can stop the process. This is about the genetic algorithms. How genetic algorithm evolve the solutions for the next generations. How new generations are implemented by using existing populations. That's it. Next, we will go to the next topic. Before going to the next topic, just see the flow chart or flow of the genetic algorithms. Here we can see initialization, fitness assignment, selection process, crossover, mutation, and we are checking the condition. Specified criteria met, we can stop. Specified criteria is not met, then again we will go through the step 2. We can do the same process until we reach the solution, until we find the optimal solutions for the next generation. This is what happens in the genetic algorithms. Now, next we will go to the next topic, that is nothing but the genetic programming. Actually, genetic programming is an extension of genetic algorithms. It was introduced by the John Koza. The basic idea behind genetic programming, we know that, right? What is the difference between algorithm? What is mean by programming? Algorithm is a step-by-step procedure to solve the particular problem. At the same time, programming can be used, or the programming language can be used to write the code for the given algorithm. So here the basic idea behind genetic programming is to represent computer programs as trees. To represent computer programs as trees. It is a subset of learning. We can use genetic programming when exact solution is not known in advance. Suppose you don't have any idea about the solution in advance. In that case, we can use genetic programming. All the operations which are carried out in the genetic algorithms like selection, crossover, and mutation, all the operations are carried out in genetic programming also. This is the basic information about the genetic programming. Now we will enter into the basic steps of genetic programming. As usual, here also we have 7 steps. Initialize the population. Initialize the population. Initialize the population. Here, create random programs for the given problem. Suppose we do have one problem. We need to find out solution to the problem. In that case, we need to write number of programs for that problem. That is known as the initialize the population. After writing the number of programs for the given problem, we need to evaluate each program. That is nothing but the evaluate fitness. Test each program to see how well it solves the problem. How much good enough a solution or a program give the solution to the problem. That is nothing but evaluate fitness. Next, after done with evaluation for each program, we need to select the best program. Which program will give the better result to the problem? That is nothing but the selection best program. Keep the best programs and remove low value or low fitness value of the programs. So we need to keep the best programs in the selection process. Next, after performing the selection process, whatever the programs we found, we need to do the crossover for that program. Suppose we found 2 programs, P1, P2 are the best programs, which are give the better solution to the problem. Now we need to do the crossover. How can we do the crossover? Mix parts of the 2 programs. Some parts of the P1 is replaced with P2. Some parts of the P2 is replaced with P1. Like that, we need to do the crossover. After performing the crossover, we need to apply mutation. We know that, right? Crossover means mixing the programs. Mutation means just we can change the small part of the program, or we can swap the small part of the program. That is nothing but the mutation. Why we need to do the mutation? To get the variety of the programs. We can find number of varieties when we are exchanging the code inside the program. That's why we are using mutation process. After completion of the mutation process, we need to form new generations. So after mixing up the P1 and P2, we got some programs, right? So that is new generation. Replace old programs with the new programs, or we can omit, or we can put as same as old programs along with the new programs also. Next, repeat. Do step 2 to step 6 as many as times until we get best program for the given problem. These are the steps involved in the genetic programming. Next, with the help of one real-time example, I am going to be explain about this 7 steps. How genetic programming can be used to solve the real-time problem. Here we consider plastic collecting robot navigation. There is a robot. There is a robot which can be used to collect the plastic in the beach area or in the river area. What is the main objective of that robot is collecting the plastic. Collecting the plastic by avoiding the obstacles. Like suppose there is rocks, there is trees, there is water zones. Avoiding these obstacles, there is a task of robot is collecting the plastic as much as possible. That is the task of robot here. That is the goal. Next, how the genetic programming can be used to do this task. Here, genetic programming help evolve or revise the robot decision logic over many generations rather than manually programming it. With the help of genetic programming, we will evolve the good strategy or good logic which can be used by the robot. That is our task. Now, step 1. Now, this plastic collection robot navigation can be explained with the help of total steps of genetic programming. Step 1 is representation. First of all, we need to understand how a robot is working. What is the basic operation of robot? Whenever we can start robot, how the robot is working. Suppose the robot task is collecting the plastic. The major task of robot is collecting the plastic and avoiding the obstacles to avoid collisions. Here, the basic operation of robot is if plastic is ahead. If plastic is ahead, then move forward. If plastic is ahead, then move forward. Else, turn left. We can write here turn right also. Turn back also. But the basic operation of robot is if plastic is ahead, then move forward. Else, turn left. Suppose the same navigation code can be represented in the complex manner, little bit complex manner, then we can go through this code. If obstacle left, if suppose there is a obstacle in the left side of the robot, obstacle is nothing but here is rock, stones or trees or water zones in the left side of the robot. In that case, what robot can do? It turn right. Suppose left side there is obstacle, then immediately robot can turn to the right side. Else, move forward. Else, move forward. These are the two basic operations which can be used to implement the logic in the robot. Implement the logic in the robot. This is the general representation of operation of the robot. How a robot can collect the plastic. So we write two codes, basic operation code and complex operation code. With the help of any one of this code, the robot can work. Okay. Now, suppose you would like to implement new technique. You would like to implement new code which can be used by the robot. With the help of that code, the robot can work efficiently. So that is our main aim. That is our main goal. With the help of genetic programming, we are evolving the new technique or new logic which can be used by the robot to collect the plastic. For that purpose, I am start with the initial population. In the initial population, what can we do? The process starts with population. Population means number of random programs. We consider here is 100 random navigation programs. These navigation programs may be representing like move forward. Suppose one program is explaining the move forward strategy. Suppose second program represents the turn left strategy. Suppose third program represents if obstacle ahead, then turn right, else move forward. Like this, we do have totally 100 programs. All 100 programs are explain the navigation strategy of the robot. Now we need to find out best program which can be used by the robot to collect the plastic. That is our main goal. Step 3. What we need to do? In the initial step, we collected population, means number of programs we do have. Now we need to find out the best program. For that purpose, what we need to do? We need to calculate the fitness of the each program. Second one is fitness evaluation. Each robot or program is run on simulated environment for a set of time like 2 minutes. So there is a robot R1. For that robot, I am giving one program P1. With the help of this P1 program, this robot is run on the simulated environment for 2 minutes. At the time of running the robot, I am calculating the fitness of that robot. Meantime, I am calculating the fitness of program also. First, suppose, how can we measure the robot or program? With the help of these components. Suppose a robot can collect the plastic, one item of plastic, then I am giving the 10 marks. Suppose a robot can done the collision. Collision means crash. It doesn't collect the plastic. If there is an obstacle, immediately it goes to the obstacle side. Then that is nothing but the collision. If collision happens, then for each collision, I am doing -5. Next, energy used. How much energy used by the robot while collecting the plastic, while running the environment? Suppose the energy used is 1 unit. 1 unit -1. Next, time efficiency. How much time taken by the robot to collect the all plastics in the environment? Suppose it finish in early, then I am giving the +5 points. By this way, we will evaluate the program or robot efficiency. Now we will see. Suppose here I am taking 3 robots. 3 robots are nothing but 3 programs: P1, P2, P3. R1 uses the P1 program, R2 uses the P2 program, R3 uses the P3 program. Like that, we will take 100 robots, or by using single robot, we can evaluate the 100 programs also. Now, I am considering only 3 robots with 3 programming cores. Suppose robot R1 collect the 5 plastic items. There is no collisions. There is no crash. Then I am giving the 5 10 50. 50 marks I given. Next, robot 2 with the program P2. It collect the 3 plastics. Then 30 marks. It done 2 collisions. That's why 10. 30 minus 10, 20. Next, robot 3 with program 3. It collect the 60 plastic items. So, I am giving the 60 marks. While collecting the plastics, it done one mistake or one crash. So, -5. So, the value is 55. By this way, I'm giving the values, fitness value to the every program. Whatever the 100 programs I have, for 100 programs, I'm giving the values 50, 20, 55 like this. After calculating the values, I'm finding the best programs. Best programs means which program or which robot having the highest value. Highest value can be considered as good programs. Now, what is the next step? After calculating the fitness of every program, we need to do the selection. Selection process is nothing but finding the best programs. Based on the fitness value, we will find out the best program. Top scoring robots or top scoring programs picked to reproduce. That is the selection process. After the completion of selection process, what we need to do? We need to mixing up them to generate the new programs. So for that purpose, I am doing crossover as well as mutation. We know that, right? What is mean by crossover? Crossover means mixing the two programs. Mutation means exchanging a small part of the program. Clear, right? Crossover means mixing the programs. Mutation means exchanging a small part of the program. Crossover. Part of two good strategies are to be combined. Suppose in the selection process, I found parent 1, parent 2. Two programs are good programs. I am taking small examples here. First parent or first program, first good program is if obstacle is left side. Sorry, if obstacle found, then turn right. Else move forward. If obstacle is found, then turn right. Here we need to write left side, sorry. If obstacle found in left side, obstacle found in left side. If there is an obstacle in the left side of the robot, then it turn left. Otherwise, move forward. That is the first good program which found in the previous step. Second parent is if plastic is near. If plastic is near, then move forward. Else, turn left. This is the second best program which found in the previous step. By taking these two programs, good programs, we need to mixing up them. So, by combining these two programs, we are generating one new child. See, if plastic is near, then move forward. I am keeping as same as here. This is mixed up with else turn right. Actually, here in the parent 2, there is a else turn left. I am mixing up with the else right turn. So, one new child, one new program is generated with the help of two good programs. That is crossover. After combining the two programs, we get one new program. So, now we need to apply the mutation. Mutation means exchange or swap some small part of the program. So, randomly change a condition or action. So, swap this turn right with the turn left. I am changing a small part of the program. That is nothing but the mutation. So, in the step 5, we done crossover, we done mutation. Now, what is the next step? Repeat for many generations. See, this process is continuous. This process is continuous. Step 2 to step 6. We need to perform all the operations number of times. We need to mixing up the good programs to generate the new programs. Until specified criteria met or until we get good program. With the help of that good program, the plastic navigated robot can work efficiently. So here, after many generations, after doing all these operations number of times, then the robot learning to scan the area, avoid the obstacles and collecting the maximum plastic efficiently. So, with the help of this code, a robot can observe the area clearly, scan the area clearly, avoid the obstacles while collecting the plastic in a efficient manner. In the less time, it will collect the more plastic. So, the best evaluated program becomes final control policy. After completion of number of generations, we will get a good program which can be used by the robot to collect the plastic. By this way, genetic programming will give the better solutions after the completion of number of evaluations. By this way, genetic program will help to plastic navigation robot. Finally, evaluated rule. After the completion of number of iterations, we will get, this is the code, this is the final code what we got. With the help of this code only, a robot can collect the plastic. Here, if plastic is near and obstacle ahead. See, the code is here. Clearly observe. If plastic is near and not obstacle found, then move forward. If there is a plastic and there is no obstacle, then we need to move the forward. Else, if obstacle is left side, then we go through the right side. Else, random turn. If suppose there is no plastic, there is no obstacle, then we need to observe the area. That's why we need to random turn. We can look at all the area. Is there any plastic is available in the area? If there is no plastic ahead or plastic placed in the area, then what can we do? A robot can sit calmly or turn off itself. That is the logic. So this is the way how genetic programming can help to the evaluate number of generations, number of solutions for the given problem. At the same time, with the help of genetic algorithms and with the help of genetic programming, we are able to find out the optimal solution for the given problem. Thank you. Thank you so much.